Good evening, everyone. So welcome to Career Launcher. My name is Naveen, and today we'll continue with our Quant CAT 2025 series. And we have started with the topic geometry. In the last couple of classes, we have seen questions based on triangles in geometry. Today, we will be doing polygons. So let's look at a few concepts when it comes to polygons. So the first concept is in a polygon, we have got first thing that sum of all the external angles, it's fixed at 360 degrees. Okay. Sum of all internal angles is given as 180 degrees into n minus 360 degrees. Now, what does n represent here? Here, n is nothing but either the sides or the vertices. Because if you have a polygon with n sides, it will have n vertices and vice versa. Right? Now, in the same case of a polygon, if a polygon is a regular polygon, then each external angle becomes 360 degrees out of n, and each internal angle, it becomes 180 degrees minus 360 degrees upon n, where n is again the number of sides and vertices. Out of all the regular polygons, the most important one is always going to be a regular hexagon. So a polygon becomes a regular polygon when all its sides and all the interior angles are equal. So if we have this regular hexagon, which is A, B, C, D, E, and F, then each interior angle is 120 degrees. Each exterior angle is 60 degrees. The length of the longest diagonal, which happens to be when we join the opposite vertices, let's say AD or BE or CF. This is given as 2 times the side of the regular hexagon. The shorter diagonal, so there are basically only 2 diagonals. Here, the shorter diagonal is going to be AC, it's going to be BD, it's going to be CE, it's going to be DF, and it's going to be then EA, and then it's going to be FP. So there are 6 shorter diagonals, and it's just given as √3 times the side. Area of a regular hexagon is given as √3 by 4 times side square, because 6 times. So basically, a regular hexagon is made up of 6 equilateral triangles. So that's why the area of one equilateral triangle will turn out to be √3 by 4 times side square. So the entire area will turn out to be 6 of that. Okay. So these are some of the basic things that we should know, we should remember. Let's look at the problems. Let A, B, C, D, E, F be a regular hexagon with each side of 1 centimeter. So we have A, B, C, D, E, and F, and side is of length 1 centimeter. The area of a square with AC as one of its sides, it's going to be how much? Now, if the side is 1, AC is nothing but the shorter diagonal, so it's going to be √3 times the side. So now if we draw a square with the side √3, the area of this square will turn out to be side square, which is going to be 3. It's as simple as that. So we do not have to draw this square here, right? Okay. Corners are cut from an equilateral triangle T to produce a regular hexagon H. Then the ratio of the area of H to the area of T is. So if we need the regular hexagon, so it should be cut something like this. And if we join them, So this is what the regular hexagon is going to look like. Now, we need to find out what would be the side of this particular regular hexagon. So it looks like it is supposed to be, one third of the side of the equilateral triangle, but it's not going to be that. So what we can do is we can take this side of the regular hexagon to be, let's say, H, right? And the leftover part of the triangle side to be T. Then this particular height plus this particular height will be the height of this entire equilateral triangle, right? So we can say that √3/2 times, which is the height of an equilateral triangle. Now, height of this equilateral triangle will be √3/2 times of its side. Here, side being h plus 2t. This is going to be √3 times h, right? Which is this. And plus, we need the height of this particular triangle. Now, this particular triangle, it's also going to be an equilateral triangle because these two sides are going to be equal. It's symmetrical. And this angle is 60 degrees. So an isosceles triangle where the top triangle or the non-base angle is 60 degrees will make it an equilateral. So if the side is t, so the height of this is going to be √3/2 times of the side. So from here, what we see is √3 gets cancelled out. So we will have h plus 2t is equal to 2h plus t, right? If we rearrange, we will have h is equal to t. So that means that if we cut down the side of an equilateral triangle into 3 equal parts, it will generate us a regular hexagon inside it. So what we have done is we have cross multiplied 2 there. So let's see if we have done any mistake. So this is the height, which is √3/2 times of h plus 2t, which is going to be height of this regular hexagon, which is the shorter diagonal, which will be √3 times the side, and the height of this equilateral triangle above, which is going to be √3/2 times the t. Fine. So we need to find the ratio of area of the regular hexagon H, right, to the area of the triangle T. So can we say that area of the regular hexagon, it's going to be 6 times of √3/4 into h square, while the area of the equilateral triangle T, it's going to be √3/4 times h plus 2t, where each t is h. So basically we are saying that it's all h. So it's going to be 3h is 2 whole square. What we will find is √3/4 cancels out, h square gets cancelled out. We are left with 6 is to 3 square, which is 9, which results in 2 is to 3. Right? So a good important property to remember that in an equilateral triangle, if I trisect each side and if I join them corresponding to the corresponding sides which are nearest points, I get a regular hexagon of side 1/3 of the equilateral triangle side. Okay. Next is let A and B be two regular polygons having A and B sides respectively. B is equal to 2A and each interior angle of B is 3/2 times each interior angle of A. Then each interior angle in degrees of a regular polygon with A plus B sides is. So we will be using the interior angle formula that we have seen in the concept today to figure out the ratio or the numbers of A and B. So if you look at A, each interior angle is going to be given as 180 degrees minus 360 degrees divided by A. If you look at B, it's going to be 180 degrees minus 360 degrees divided by B. But we are told that each interior angle of B is 3 by 2 times of this. We are also told that B is equal to 2A. So basically what we can do is, instead of B, we can put in 2A. Let's simplify this. We will get the value of A here. So what we get is, if we rearrange, we will have 3 times of 180 degrees minus 3 times of 360 degrees upon A is equal to 2 times of 180 degrees minus 2 times of 360 degrees upon 2A, which is going to be 360 degrees upon A. Now, if we cancel out 180 degrees throughout, so this is 180, this is 180 into 2, this is 180, this is 180 into 2. So we get 3 minus 6 upon A is equal to 2 minus 2 upon A. Now, if we rearrange, we will be getting 6 by A minus 2 by A is equal to 3 minus 2. Or from here, we will be getting A is equal to 4. So we are talking about quadrilateral here. So if A turns out to be 4, B turns out to be 8. So now we need a regular polygon with A plus B, that's 12 sides. What would be the interior angle of this? Well, interior angle, the formula stays the same, which is going to be 180 degrees minus 360 degrees out of 12. 360 by 12 is nothing but 30 degrees. So we get 150 degrees. Theta, so I'll put in 150. Right? Okay. Next, if the area of a regular hexagon is equal to area of an equilateral triangle of side 12 centimeter, then the length in centimeter of each side of the hexagon is. So we have areas equated. So area of a regular hexagon is 6 times of root 3 by 4 into side of the regular hexagon square. And area of an equilateral triangle of side 12 is given as root 3 by 4 times 12 square. So from here, we are told that they are equal, right? So root 3 by 4 is gone. So what we get from here is side, it's going to be 12 into 12 upon 6, right? Which is going to be 12 into 2, which is 24. So we will have under root 24 here. Under root 24, it's going to be nothing but 2 under root 6. So each side of the hexagon, it's going to be 2 under root 6. Well, when it comes to polygons in CAT, do not expect a very difficult problem. So the questions are generally based on the equations, the general formulas of polygon, regular hexagon. Worst case, in the past 15, 16 years, there have been a couple of scenarios, couple of years where we have got polygons based on octagons. So just go through the interior angle, exterior angle, regular octagon, it's all good. The area of a regular octagon is something that you should simply look into it and remember it. Okay. You do not have to prove it. You do not have to solve it during the exam. So if required, you will have to straight away use that formula. Okay, next. Suppose the length of each side of a regular polygon A, B, C, D, E, F is 2 centimeter. If T is the midpoint of CD, so this is T and it's the midpoint, then we need to find out the length of AT. Well, if we join AC, what happens is we get a right angle triangle here. Now, why do we get a right angle triangle there? So ABC is an isosceles triangle for sure, because AB and BC, they are equal sides of a regular hexagon. And this angle is 120 degrees. That means this angle is going to be 30 degrees. The other is also 30, so that the sum is 180. Sum of interior angles of a triangle. Now, the angle at C is also supposed to be 120. Out of 120, if 30 is there, so that means we will have 90 degrees here. So what we see here is a right triangle, which is ACT. We can use Pythagoras theorem here to solve this. So AC is going to be nothing but the shorter diagonal, which we have seen as root 3 times the side. CT is going to be half of the side. And AT is something which we will calculate using Pythagoras theorem, because AT is the hypotenuse of this right angle triangle. So this is going to be 2 under root 3 whole square plus 1 square. So this is going to be 4 into 3, 12 plus 1, which will result in under root 13. So the length of AT is root under root 13. Right? Okay. Another question on regular polygon. So regular polygons A and B have number of sides in the ratio 1:2. So if you talk about A and B and the sides, it's 1 and it's 2. And if you talk about interior angle, it is 3 and 4. So we need to find out the number of sides of B. So interior angle is given as 180 degrees minus 360 degrees upon the number of sides of the regular polygon, right? So if I take this as 1x or 1s as the side and 2s as the side, so when it comes to regular polygon A, its interior angle, which is 180 degrees minus 360 upon S, and that of the regular polygon B, it's 180 degrees minus 360 degrees upon 2S. This is in the ratio of 3:4. So once we figure out S, we'll have to double it, because S is not what is asked. We are asked number of sides of B. So 2S find out. If we take the LCM of the left-hand side numerator and denominator, and if we are able to get rid of 180 right here, it's going to be super beneficial for us. So what we get is S minus 2, and the 2 from the denominator will go up, and it's going to be 2S minus 2. And this gives us 3/4. Now 2 cancels out from both the numerator and denominator of the left hand side. So we'll get S minus 2 upon S minus 1 is equal to 3/4. So either you cross multiply or solve, or if you think about it, the numerator is 1 less than the denominator. So this will only happen if you write it like this. And if you compare, we realize that S is 5. If S is going to be 5, 2S will be 10. So if you remember the formula, the next couple of steps, it's all about how quickly you are able to solve the equations, right? So you can see that most of the questions, these are based on regular hexagon, or they are based on polygons or regular polygons, right? Regular octagon is kind of an obsolete topic. So Mr. Shashank is going to take your next session of your roadmap to QA success. It's going to happen on 6th of May, Tuesday at 8:30 p.m. He will be taking the 5th session of arithmetic, wherein he will be discussing ratio and proportion part. So make sure that you join this free session live on YouTube at 8:30 p.m. 6th of May, Tuesday. Okay, do not miss this. It's like you're getting the concepts as well as the questions for free, right? And we are very much thrilled and happy to announce that 107 CL students, they have till date made it to FMS Delhi. These all are audited results. And 119 final selections are in IIM Ahmedabad from Career Launcher, our own students. Okay. So the numbers are growing week over week as the results have come up. We are getting in touch with our students. So it's almost like a little over 30% of the batch of IIM Ahmedabad this year is our students, right? Isn't that great? So if you guys have any questions, feel free to ask. In case if you're watching it once the live session is over, you can ask it in the comment section below. We will reply. Okay, any query that you have. Thank you. Thank you for joining. Please make sure that you subscribe to the channel if you haven't yet. Like the video and share it with your friends. Until next class, take care. Bye-bye.